the knowledge from the previous slides, right? Which is division algorithm extended to finding greatest common divisor and so on. So for example, express the greatest common divisor of 132 and 424 in the form of 132s and 424t's. That's what we're trying to do. Yeah, we're trying to express in terms of another two unknown. Okay, so from the previous working, we have got 424 equals to 132. Okay, this one, this simply means 132 times with 3 plus 28. And then what we do is we are going to make, for each line that we calculated in the previous slide, we're going to make the divisor as the subject of the equation. So it's 28 equals to 424, take away 132 times 3. Okay, and then same goes for the next line, right? We're going to make the remainder as the subject. Same goes for the coming line, 8 becomes the subject. And same goes for the last line, and the second last line, and also the last line. 0 equals to 8 minus 4 multiplied by 2. So once you get that, now you have to work out, you get the, identify the S and the T. So in order to get that, we're going to work line by line. So your next, of course, the greatest common divisor here was identified at this line, all right? And in this case, we continue with the same working from the previous slide, and we need to identify. So line A, actually, so we start off with the lowest line, with the lowest value first. 4 equals to 20 minus 2 times 8 times 2, or 2 times 8. Okay, and now we need to substitute line B into line A. Yeah, so what we're going to do here, we're going to substitute line B as 8. So line B says 8 is actually 28 minus 20 times 1. So we're going to substitute this equivalent over here. So this 8 equals to 28 minus 20 times 1 goes here. Right? So this will give you, so you see I've substituted this as equivalent to 8. Okay, and then the next step would be simply trying to simplify this, but bear in mind, when you simplify, you actually leave the multiples of 20, and you just combine the multiples, as in this is 1 of 20, 1 of 20, and 2 of 28, so it becomes 3 of 20s and minus 2 of 2 multiplied by 28. Right, so don't bother multiplying it, just leave it in terms of 20, 28, and so on. Okay, simply because in the coming lines we're going to substitute. So the next line, that is C, so when we substitute line C, we have actually equivalent of 20 in line C. So 20 is actually this, right? So we're going to substitute 20 over here. Okay, so in this case, say 20 is being substituted over here, right? And then next we actually simplify. It is 3 times 132 minus 3 times 4, 12 of 28 minus 2 of 28, and then we combine the alike terms together. So 12 minus 2 is minus 14. Okay, and next, now the next line here we have 28. The next line above here now is 28. So we're going to substitute equivalent of 28 into 28 over here. So what we're going to do here is we're going to substitute the equivalent of 28 into 28 over here. So what we're going to do here is this line D to substitute for 28. So 28 goes here, 14 of 28. Alright, and then we expand it. So 3 times 132 minus 14 times 424 minus 132, and then this becomes 42 of 132, right? And we substitute it here. We collect the 132 terms together and the multiples of 424 together, right? and we will actually get 14 multiplied by we get 45 times 132 minus 14 times 44. And if you realize, this actually fulfills the question, because the question actually said we are looking for multiple of 132 and also multiple of 424. So comparatively, and 4 is obviously the greatest common divisor, right? We started off with the 4 here, right? Okay. For this next example, we are required to show that 280 and 117 are relatively prime. And for part B, we actually need to apply the Euclidean algorithm to solve, determine the value of A and B given 280 and 117 equals to 1. Multiple of A and B equals to 1, yeah? So this part A, we need to show whether that 280 and 117 are relatively prime. So for that, we actually can look for the greatest common divisor. Okay, so we start off with 280 divided by 117. So it's simply 280 equals to 117 times 2, and the remainder is 46. And then we make because later on for part B, we need to do Euclidean algorithm. So we might as well make the remainder as the subject of the equation, right? And then as usual for the next line, we simply divide the quotient 117 divided by the remainder. So it's simply 117 divided by 46. It will be 2 times 46, and the remainder is 25. And then over here we make 25 as the subject of the equation. For the next line, we simply divide the quotient 46 with the remainder 25. Okay, so it will simply be 46 equals to 25 times 1, and with remainder 21. And we make here the remainder as the subject of the equation. And for the next line, we simply take the quotient 25 divide with the remainder 21. So 25 equals to 1 times 21 at 4. Okay, and then we make 4 as the subject of the equation. And for the next line, we continue 21 divided by 4. Okay, 21 is the divisor, divided by 4 being the remainder. Sorry, 21 being the quotient, divided by 4 being the remainder. So 21 divided by 4 is simply 4 times 5 plus 1. So now we have actually got 1. So we have actually proven that the greatest common divisor is actually 1 for 280 and 117. Therefore, these two numbers are relatively prime numbers, yeah? Okay, so this is the conclusion for part A. For part B, we simply need to work towards getting multiples of 280 and 117, right? So in this case, as usual, based on the previous example, we start off with the lowest line, 1 equals to 21 minus 4 multiplied by 5, right? So we need to substitute 4, equivalent of 4 into the earlier line. So we will actually substitute 4 equivalent to 25 minus 21 times 1 over here. Okay, so when we substitute the equivalent, 5 times with 4, the 4 is this equivalent. Okay, and then the next step, we actually simplify it. Okay, we collect the multiple of 21 and 25 individually, right? And then we will get 6 times 21 minus 5 times 25. Right, so now for the next line, you actually have 21, which is the line here. 21 equals to this. So we're going to substitute the equivalent of 21 over here as 21. So in this case, this orange color is substituted as 21. 6 times 21 multiplied by 5 times 25. Okay, so we simplify it first. We have to do it step by step, yeah? So we simplify it first, and we leave it in terms of 6 times 46 minus 11 by 25. Okay, so the next step here will be substituting a line later. Okay, so for that, we have 25 over here, so we're going to substitute 25. So you go layer by layer, you go from bottom to up, yeah, don't jump steps. Okay, so 25 is equivalent to the green color circle here. So we substitute 117 minus 46 multiplied by 2 as 25. So you substitute it and then you leave it as a multiple of the number 46 and also 117. Okay, and then for the next line here you have 46. So you're going to substitute the equivalent of 46 into this particular line, and this will reduce the line to being multiple of 280 and 117, and you have no any more lines to substitute, and